condition, you will be asked to derive that condition. In capacitor, we are simply using this condition. Derivation is not there, but we have derived there also. So here also we will derive. So this is Wheatstone's bridge. So why this name is given, Wheatstone bridge, or why bridge is there? Suppose we are given, this is one resistance, this is another resistance. So when source is connected between these two terminals, and one more resistance is connected these two line, you can say. Like river is flowing in this, and one bridge is made here from this bank to that bank. That's why the name is Wheatstone bridge. Dipasu, Johan and Eli is still, where is that? Where is he? So that's why the name is Wheatstone bridge. Circuit may be this type, or like in, so this is also Wheatstone bridge. If the circuit is this way, then also it is Wheatstone bridge. Or it may be the other way is, we are generally, you will find this type of circuit. So these are the four resistance. There is no difference between this circuit and this circuit. Either you may get this type of diagram or this type of diagram. Now this two terminal is connected by maybe another resistance or maybe a galvanometer we are taking. Galvanometer also has got this some resistance. So we are naming it, suppose this is P, this is Q, this is X, and this is R. So four resistors are connected this way. Now, one galvanometer is connected to these opposite diagonally opposite points, and to the other diagonally opposite point, the source is connected. So the source is connected between these two opposite A, B, E, B. So if you are asked to derive this condition for balanced Wheatstone bridge, then you will draw the diagram and then you will write, let us consider, like that you will write. So let us consider four resistances P, Q, X, and R connected as shown in the diagram. A sensitive galvanometer is connected between the point B and D. That is, we say the opposite junction. One junction here, opposite junction here. And a cell or the source is connected between the remaining two junctions. Four junctions are there here. These two are joining. These two are meeting at this place. Q and R are meeting at this place. So these are the junctions. Here X, R, and this G is meeting. Now the resistance of this galvanometer, we are saying it is G. Galvanometer will have some resistance. Galvanometer is an instrument that detects the current. It does not measure current. It simply detects whether the current is flowing or not. If it is flowing, then in which direction it is flowing. So this galvanometer is a very sensitive instrument. So we have to pass very small current through the galvanometer. If the galvanometer is connected like this, then in series, one more very high resistance is connected. So in order to save the galvanometer, if we are connecting this way, then high resistance is also connected. Okay, so this is all like that. Now we are going to find what should be the value of PQR in terms of X, or what should be the value of X in terms of PQ and R in order to get it balanced. Balance means what? In capacitor we have done. What is the meaning of balance? Here, go through this one, this branch. That is, galvanometer will show no deflection. Then only we say the bridge is balanced. What happened? The first was so we have to derive that condition. In general, suppose first we are writing the equation. Suppose the current passing through this is I1, this is I2. From here the current is I1 plus I2. If the bridge is balanced, then whatever I1 is here, same will be here also. But we are taking first general condition because we have to solve the numerical also afterwards. If bridge is not balanced, then how will you solve the problem? Suppose this out of this I1, some current Ig is passing this one. And here it is I3, and here it is I2. So if we apply junction, so let that current be, current drawn from the source be divided as shown in the figure. Simply you will write that much. No need to say this much current is passing through this much current is passing through this. No. The current so if we apply Kirchhoff's first law at junction B, first law for junction B, what will be? At junction B, what is happening? This I1 is coming and I3 and Ig both are going out. So that will be, that means I1 will be equal to I3 plus Ig. And for junction D, What is happening here? I2 is arriving at this junction, IG is also arriving at this junction, and I4 is coming out. So what will be this? I2 plus IG will be equal to I4. When we solve the numerical, we will not go in detail. What will be? This is I1. Here it will become directly, we'll write I1 minus IG. So IG has gone this way. So I1 minus IG. So like that we can write the. Now if we apply second law for closed loop, ABDA. What will be? While deriving this part, you may leave also directly. We can write if the bridge is balanced, so IG will be 0. Naturally, I1 will be equal to I3, I2 will be equal to I4, and then you will write this mesh law. But general first we will see. After that, we will apply that condition. So what will be for this one? A, B, D, A. We are using our concept. We are moving from higher potential to lower potential. So difference is VA minus VB, that is positive. According to book, if you are writing, then what will be? We are moving from higher to lower. So in that case, we are saying final minus initial, that is VB minus VA, that is negative. So whatever concept you can, we will use our concept, whatever we applied in capacitor, same concept will apply. Because you have not to write what concept you have applied. Equation should be correct. So it is I1P plus IG into G minus I2 into X equal to 0. And for closed loop, BCDB. What is that? I3Q minus I4 into R minus IG into G equal to 0. According to the concept which is given in the book, which one consider positive, which one negative, then what will be? We will take minus sign all everywhere, same thing will come. That is, this will become minus, this will come minus, this plus. If you take minus sign common, it will come like this. This is the general one. Sometime what will be? You will be given the problem of unknown, and you will be asked how much current is passing through galvanometer or how much current is passing through this. In that case, there are three variables here. I3 means what? I1 minus IG. I4 is what? I2 plus IG. So these two are not variable. It's not unknown. Unknown is I1, I2 and IG. Three unknown are there. And we will get only two equations. Then third equation will be, in that case, you will be given this source, EMF. You have to write the equation for this closed mesh, or you have to write the for this closed mesh If source EMF will be given, then only these things will be unknown, means unbalanced one. Then source will be given and we will find the current. If current is not asked, but simply equivalent resistance is asked, then these two equations will be sufficient and that will solve afterwards. If bridge is unbalanced, then how will you find unknown resistance? And that we have done in case of capacitor also. Okay, so if bridge is balanced, now what will be? This Ig must be 0. That is, galvanometer must show no deflection. And we are interested to find that condition only. So for bridge to be balanced, galvanometer must show no deflection. That is, this Ig must be 0. So when Ig is 0, no current will flow through this. That means potential at V and potential at D is same. Potential difference between A and B and potential difference between A and D is same. These are the other things. So for the timing, we will concentrate on this condition, that is Ig 0. Then what will be from first? If Ig is 0, then I1 will be I3. Therefore, this I1 must be equal to I3. First equation. Second, from second, what will you get? I2 will be equal to I4. From third, what will you get? I1P, this is 0, minus I2X is 0. And from fourth, what will you get? I3Q minus I4R. This is 0 only, Ig equal to 0. So I3 over I4 will be R over Q. Now I3 is I1, I4 is I2. So what does it mean? This I1 over I2 is R by Q. So from 5 and 6, what do we get? X over P is R by Q or P by Q is X by R. That is this by this equal to this by this, or this by this equal to this by this, or P by X equal to Q by R. Or it may be P over X equal to Q by R. So anyway we have to find either this by this must be equal to this by this, or this by this must be equal to this by this. So this is the condition for balanced Wheatstone bricks. Any confusion? Anyone?
No, sir.
No. Now, what are the other information or what are the other conditions that will be satisfied during balanced Wheatstone bricks? So derivation up to here only you will find, either here or here, anywhere you leave, no problem. So if 3 marks question generally it is asked, derivation means up to here. You can skip the first part also without balance condition if you are writing the equation. You may not write that also, no problem. Directly we will start from as the bridge is balanced or the bridge will be balanced if galvanometer shows no deflection. So Ig is 0, that is here also we will write I1, I3 is equal to I1, I4 equal to I2, and then you write the equation of mesh equation. Okay. Now what are the conditions or informations we can say applicable or that is which is conveyed, we can say or balance. Okay. Other information what are the so first is what? This Ig is 0. Okay. That is one condition. No current will pass through this. I3 is I1 and this I4 is I2. So whatever current is passing through this, same current will pass through this one. Whatever current is passing through this, same current will pass through this one. The second is potential of B and potential of D are same. That means whether these two points are connected by any resistance or they are not connected. There will be no effect on the circuit when the bridge is balanced. These two potential are same. So whether you are connecting them by wire or by any resistance, nothing is going to affect. So this resistance will become just useless. So this VA minus VB will be equal to VA minus VD because B and D are so potential difference between A and DB or A and D are same. Similarly, this VB minus VC will be equal to VD minus VC. And what is the equivalent? Resistance, this RAC, if you are finding that, what will be? These two will come in series, these two will come in series, and then their parallel equivalent. So it is P plus Q into X plus R by P plus Q plus X plus R. So these are the other information that we are getting from this condition. Or if any one of this condition is satisfied, we say bridge is balanced. Either there is no deflection shown by this, or it is given potential difference between A and B and potential difference between A and D are same in the question paper. That means this is the condition of balanced bridge. Now, this is 2 ohm, this is 4 ohm, 6 ohm, 12 ohm, and this is suppose 5. You are asked find the equivalent resistance between A and B. So this is the circuit of Wheatstone bridge. So first we will check whether it is balanced or not. So this is balanced. This by this equal to this by this, or this by this equal to this by this. Balanced means this will become useless. So what will be RAB? These two are in series. So 6 into these two are in series. 18 by 6 plus 18.
9/2.
What point 5 no?
So that only 9/2.
Huh?
Yes, sir. Yes, sir. So that only 9. Yes, sir.
Yeah, 9 by 2 you can say. Okay. So it will become 4.5 ohm. Okay. All are R only. Suppose we are asked find the equivalent resistance This type of sum we have done in case of capacitor. Same thing is there. Wheatstone bridge will come. In capacitor also we have seen. So here also, if you are getting this type of element of 5 resistance, it is Wheatstone bridge. So what is happening here? Suppose this is point A and this is point C. Now between C and E, one resistance is there. Okay, we say this is point E.
Said 3R.
This is R. E and D, yes.
3R.
How much? 3R.
3R.
3R. So this is D. Now between D and E, one resistance is there. So this is one. So with this one we consider. What is that? Between D and F. So between D and F, E and F, one resistance is there. And F and other. So this is Wheatstone bridge and this is balanced one. So this R is useless. Means no current will be going this way. So simply what will be, whatever current is coming from here, it will be divided in this part and this part. Those two resistors are same. So this equal division will be there. After that again it will combine and here. So these R and R, 2R, this is 2R, parallel equivalent. R, so simply this RAB will be R plus 2R into 2R by 2R plus 2R plus R. So it is 3R. So this way we have to think some rearrangement, how it can be done. Many we have done in case of capacitors. So same concept you have to apply here also. There is no other different concept. Here also same concept. Whatever we have used in case of capacitor. Now here some more thing will come. That is symmetry. How we'll apply the symmetry principle here. So tomorrow we shall see that part. Equivalent resistance. How will you find? By applying principle of symmetry or symmetry, property of symmetry we can say. Okay, so we'll leave up to here. Yes.